ओके, सो स्क्रीन नजर आ रही है सबको, राइट?
Yes, sir.
So today's lecture is lecture number 10 and this is about the estimation of road works. अगर आप लोगों का पिछले लेक्चर्स में कोई क्वेश्चन है तो आप लोग पूछ सकते हैं।
No, sir.
Okay, fine. So estimation of road works में नॉर्मली हम देखते हैं कि कितनी एक्सकवेशन है और कितनी कटिंग है, सॉरी कितनी एक्सकवेशन और कितनी फिलिंग है। तो we will calculate the quantities of the filling of material and where the cutting is required, we'll calculate the cutting of that material. So normally you have seen that the roads are constructed, or highways or motorways are constructed in a trapezoidal way. If you take a section at any point, so you'll see a trapezium like this, or if it is in cutting and the road is going below the ground level, so you'll see the section like this. तो इसमें अगर देखा जाए तो the top surface, the having the width B is the formation level or finished surface level at which the road at which the vehicles will travel, and D is the depth of filling. And there are two triangles there on the sides. So the hypotenuse is having a ratio, or the slope of this hypotenuse is S ratio 1, where S is the slope. So in the examples we'll see you'll be provided slope in the form of S ratio 1. S may be any number, 2 ratio 1, 3 ratio 1, 4 ratio 1. So this actually means that if there is 1 unit of depth, then there will be S units of horizontal distance, or you can say for every S units of horizontal distance there is 1 unit of depth. So if I have let's say D times depth, if the depth of the filling is D, so what will be the this horizontal distance? Definitely S times D. So I have D, I have SD. So if I want to calculate the area of this triangle, the area of the triangle will be half of D into SD, or you can say half of SD square. Now we have two triangles, so the area of two triangles will be SD square, and the total area of this trapezium will be B into D plus SD square. So this is the area of the this trapezium, BD plus SD square. Same will be the case for the cutting. There's the B breadth and these the depth, and these are two triangles and having the side slopes having the ratio of S ratio 1. So same formula is also applicable to this cutting portion as well. So if you look at this segment of the road, this This road is constructed in, if you take a section, it will look like a trapezoid. But the roads may be may have different elevations. For example, depending upon the layout, this D1, the depth of the trapezium at this point might be different from the depth of the trapezium at this point. So this may be 4 meters and this may be 8 meters, because if the road is running upward, or this may be 8 meters, and this may be 4 meters if the road is going downward, sloping downward in the longitudinal section. So how you will calculate the quantities of the filling material in this whole road segment? यहाँ पे quantities कैसे calculate करेंगे?
I think use different length. Just take same elevations and just found the volume, and then take another same elevations and take the volume.
No, but there is no concept of same elevations. The road is constantly going upward. This is not going like in the form of stairs, like the road is having depth D1 till this point, and then D2 till this, from this point to onwards this point. This is slowly and gradually increasing towards the D2. So the D is constantly changing at every single point.
Then consider it as incline and found the hypotenuse of the triangle of inclination, and then accordingly take the length.
Okay. Good attempt. Anyway. Any other idea? Okay. If I take D1 plus D2 and divide them by 2, so I'll get the average. I'll get the average depth, or if I say I'll get a depth at this midpoint. So let's take average of D1 and D2, and we will get a depth at this midpoint, which will be the average of these two depths. Now, if I take this depth and calculate the area of this section at this midpoint, depending upon this depth. So how you will calculate the area? You know what is the D, the average D, you know what is the B value, and S slope is given to you. So you can calculate the area of the section at this mid point. So once you have calculated the area of the midpoint, so multiply that area with the length of the road, and you'll get the volume of that material. Or you can adopt another approach as well. You can calculate the area of this road section at this point, then calculate the area of the road section at this point, then take the average area and then multiply that average area with the length of the road, and you'll get the volume of that material. So let's introduce you people with some terminologies: lead and lift. So what is lead and what is lift? if you're a contractor and doing excavation in the field for construction of a road, so if you have quoted a rate of excavation and you are asked to do excavation in the road, excavate the road material and dump it like 1 kilometer away from the excavation point. So it would increase definitely the cost of the excavation, because you are picking up the material and going 1 kilometer away from the site and then depositing that material there and coming back towards the excavation point. So definitely it would increase the cost of your excavation, for which you are not prepared, or which may decrease your profit, or which may take you into loss. So normally the rates of excavation or filling are based upon normal lead and normal lift. Now, what is lead and what is lift? The lead is the average horizontal distance between the center of excavation and the center of deposition, whereas the lift is the average vertical distance or vertical height between the point of excavation and point of deposition or spreading. Like you are excavating a soil below the ground level and lifting it up to the ground level. So the vertical average distance between the point of excavation and the deposition is basically called as lift. So when you are quoting a rate of excavation, so it's for the normal lead and normal lift, and the normal lead is 30 meters, and the normal lift is 1.5 meters. So let's say the distance between the point of excavation and point of deposition is increased. So your rate will increase in the intervals of 30 meters. For example, from a normal lead of 30 meters to 0 meters to 30 meters, your rate will be X. Now, if the distance between the point of excavation and point of deposition is increased, so you increase, let's say, and now the distance is, let's say, 45 meters. So now you will increase the rate, your cost. Again, it is increased, let's say, up to 50 meters. Now you don't need to change your cost, and you'll stick your you don't need to change your charges, and you'll stick to your rate up to 60 meters. So simply speaking, you will increase your rate in the intervals of normal lead and normal lift. You'll not increase your rate for every single meter or every 2 meters. For every 2 meters, you'll increase your rate after 30 meters of lead and 1.5 meters of lift. Is it clear?
Sir, lead and lift are not clear for me.
Yes, sir.
Okay.
What are they?
What do you mean by yes? Clear or not?
I said lead and lift are not clear.
Okay.
The slide before this one.
Yes. Let's say you're excavating soil for construction of a road. So
Yes.
you're picking the soil from this point and depositing it here, then coming back towards this excavation point, then coming excavating the soil and going to this point and depositing the soil. So the average distance between these 2 points is basically called as lead, horizontal distance.
Okay.
And if we talk about the lift, so let's say the ground level is at this point, and you are excavating at this location.
Yes.
Now you are excavating the soil and lifting the soil up and depositing here at some height. So the average distance between these 2 points will be called as lift. What the average vertical distance I'm talking about.
Okay. Lead for horizontal distance, lift for vertical.
Yes, and they are required for defining the charges of excavation and lift. Excavation based upon the distance between the point of excavation and point of deposition, because definitely the charges or the cost of the excavation will increase if you increase the distance between the excavation point and the deposition point. You will need to travel a much longer distance if you increase the lead for depositing the soil.
Okay. No.
Okay. Now there is some discussion on how and what are the factors involved in fixing the road profile, which you might know. Do you have studied in these topics in the transportation engineering? How you fix a road profile? What are the factors involved in the fixing the road profile? Do you know what is road profile actually? कोई आइडिया है रोड प्रोफाइल होती क्या है या फॉर्मेशन लेवल?
Not sure.
Okay, so I should not ask you people how to fix it because you don't know what is road profile actually. Let's say let me show you a figure. Let's say some surveyors conducted a survey for getting an idea about the road condition. Where is the road in going up, and where is it is going downwards, and what is the what is the ground profile. So this horizontal distance is showing you the horizontal distance is showing you the horizontal distance of the road. For example, 0 meters, then 30 meters, then 60 meters, then 90 meters, then 120 meters, so and so on. So you are going horizontally. Now you are actually measuring the road reduced level, road height from any reference level. So at this distance, the road was having height of this much. Then you move towards the 30 meter point horizontally. The road height increased till this point. Then you moved ahead and road height decreased a little bit. Then you not the road height. I'm talking about actually the ground profile. The road is not constructed yet, so it is uneven. So you can see that the ground is uneven. It is going upward and downward, and some the slopes are not regular. A car if a car is traveling on this type of ground level or ground surface or ground profile, so it will be difficult for the vehicles. Now you have to fix a formation line. This is the formation line, and this formation line is fixed based upon different vectors. Now this is the line, or this is the height of the road after construction. The road will follow this path. At this point, the road height will be 107 meters, and it will decrease slowly and gradually, and the slope will change at this point, and it will again slowly decrease. The height will slowly decrease. Now you can see that the road profile is higher than the ground level. The road profile is higher than the ground level. So what does it mean?
We need some fills.
Yes, definitely. You need to fill this portion to construct a road which is having a level of this much. Again, you can see that here the road, the ground level is below the road profile, because you have to provide a smooth surface to the vehicles. So you have to maintain a uniform slope throughout the road profile. So again, you need to fill that portion, but the amount of filling required at this point will be less as compared to this point, and so on. If the ground profile was above the formation level, then you have to cut that portion in order to provide, otherwise the vehicle will come straight like this, and it will have to travel upward and then downward to travel from the ground profile. But actually you need to cut that ground profile and provide a leveled surface, properly leveled surface to the vehicles. So this is basically the formation level. Now the depth D is showing you this height or depth of filling or depth of cutting. So what will be the factors? What should be the factors which should be considered while fixing the formation line? There are many factors, but some important factors are flood level. So flood level, you can see the motorways in Pakistan. They are constructed much higher than the ground level. This is because in case of any floods or any such event, the road might be in operational condition. Another important factor is gradient. You need to take care of the gradient of the road or slope of the road. The formation level of the ground or the formation level of the road surface should be such that the slope is not too much for the vehicle to travel on the road. ये ना हो कि आप कोई ऐसा स्लोप प्रोवाइड कर दें, स्टीप स्लोप प्रोवाइड कर दें कि उस पे फिर व्हीकल्स उस पे ट्रैवल ही ना कर सकें. Then other important factors are height of bank and depth of cutting. So you have to take care that not too much amount of cutting or filling is required at any location. Otherwise, it will increase the cost of the project. Normally, if there is some cutting, if the road is partially in filling and partially in cutting, so normally the cutted material, the excavated material, is then used for the filling of the next section of the road. so that you might not have to travel a longer distance and bring that filling material for filling purpose. You can utilize that material which is excavated from some other segment of the road, and then you can use that material for the filling purpose of that road. Then there is some discussion about the okay. Look at this figure. In this figure, the formation, if you are provided with the reduced levels of the formation level, and you are also provided with the reduced level of the ground surface. So, can you calculate the height of the filling?
I think the same one which you calculate in the beginning. We'll take the average, the beginning of the line and the end of the line, and then we'll take the average of them.
No. If I ask you what will be the height of filling at this point, that was for the whole road segment. I'm just asking about the each individual point. Let's say I'm taking measurements at this point. So what will be the height of filling at this point?
Yes, take the elevations in the point where I want to make filling, and then I'll take the elevations up to where I want to fill. So take the difference between them, then it will give you the height.
Yes, the difference between the formation level, and the difference between the height of the formation level or reduced level of the formation level and the reduced level of the ground level. This will give you the height of filling or depth of filling. And if the value comes to be negative, then what does it mean?
That's mean it's cutting, not filling.
Yes, cutting, because the it will mean that the ground level is higher than the formation level, and you need to cut the ground level, ground material, so that it can be in level with the formation line. Also, during the surveys, during the road survey or the ground survey, in which you normally take the in which you normally figure out the profile of the ground, the levels or the intervals between the measurement point are depending upon the nature of the ground or nature of the road surface or the ground surface. So if it is a hilly area and there are much more ups and downs on the ground, so you will decrease the interval of the taking measurements. But if it is a fairly level surface and there are no significant ups and downs on the ground surface, so you can take the interval much higher for taking the measurements. I think these things you might have studied in the survey 1 or survey 2 course. सर्वे 2 में आप लोगों ने लैब की ये सॉरी वो की है फ्लाई लेवलिंग.
यस सर, सर्वे 1 में किया सर.
तो उसमें आपने इंटरवल्स लेते हैं ना, हर एक थोड़े थोड़े इंटरवल के बाद आप रीडिंग्स लेते हैं.
यस सर, अमाउंट ऑफ कट और फील मेंटल.
यस, सो वही टॉपिक है ये भी. Okay, so for computing the volume of the earthwork, you can use three methods, any of them: mid sectional area method, then mean sectional area method, and then trapezoidal formula. So in the mid sectional area method, you have to take the average depth. You will take the depth of the road at one point and the other point, and then take the average of these two depths, and you will get the depth of the midpoint. Now calculate the area of that mid section and multiply with the length of that road segment, and you will get the volume of the material. In the mean sectional area method, you have to take the area of the cross-sectional area of the one end of the road, and then on the other end of the road, and then take the average of that area, and then multiply it with the length of the road segment, and you'll get the volume of that earthwork material. And we'll see the trapezoidal formula at the end. So in the mid-sectional area method, you can use this type of table for organizing the values. In this table, the first column is about chainage, then the depth, then the average depth. Take the average of the first value and the second value and write it here. Then the average of second value and third value and write it here, and so on. Area of mid portion will be equal to the B into D. B into or here, and D is replaced by H, so B into H. Use the average H here. So area of this area of the mid portion, then area of the side parts will be equal to SH square. This is based upon the formula we have derived at the start, BD plus SD square. Here the D is replaced by H. So area of the side parts are SH square, and the total area will be BH plus SH square. Distance between 2 points, distance between these two chainages will be written here, and multiply this length with the total area, and you'll get the volume of the earthwork either in the cutting or either in the filling. Similarly, for the mean sectional area method, you can use the similar table, but there will be a slight difference. The same chainage will come here, then depth, then mid area. Then now you are not taking the average of the average of the depth as we have done in the previous case. Now you have to calculate directly the area of the section at each chainage. So area of the mid portion, area of the side parts, total area. For each chainage, you will calculate the total area, then calculate the mean area. Take the first area, take the second area, and take calculate the average. Write it here. Then average of second and third, write it here. Then third and fourth, write it here. Then multiply these areas with the length or distance between these two chainages, and you get the quantity of earthwork in either cutting or either in filling. Then comes the trapezoidal formula. So let's see how it works. In this formula is assuming that the section between the road segment between two chainages is trapezium, or is like a trapezoid. So the volume of earthwork between two road sections will be equal to A1 plus A2 divided by 2. This will give you the average area. Multiply it with the distance between these 2 points, or distance between these two sections. This will give you the volume of earthwork in the first segment of the road. Then calculate the volume of the earthwork for the second segment of the road, and the second segment will be bounded by the areas A2 and A3. So A2 plus A3 divided by 2, this will give you the average area, and multiply that average area with the distance between 2 points or these two sections. This will give you the volume of earthwork for the next segment of the road, and similarly you can calculate the volume for the other segments of the road as well. Now what will be the total volume? You have to add all of these values. So d by 2 a1 plus a2 plus d by 2 a2 plus a3 plus d by 2 a3 plus a3. So you can see that d by 2 is common in all of these. So you can take d by 2 common, and the rest of the values will be inside the bracket a1 plus a2 plus a2 plus a1 plus a2 plus a2 plus a3 plus a3 plus a4. You can see this. So if I add these two terms, so a1 plus 2a2 plus 2a3 plus a4. Now you can see that the in this expression, the first and the last areas are repeating single time, are appearing single time, and all of the intermediate areas are getting repeated 2 times. So I can generalize this formula like the total volume of the earthwork will be equal to d by 2 into a1 plus a2 plus a1 plus 2a2 plus 2a3 plus 2a4 plus 2a5 plus 2a6 and so on till 2n minus 1 plus an. The an is again appearing single time. So a1 and the last area is appearing single time, and all of the intermediate areas are repeating 2 times. Is it clear?
Yes, sir.
Okay. So let's jump into an example. Example number 1. This is a very simple example. You have to calculate the quantity of earthwork for a road having a length of 200 meters. And the ends are having a height of 1 meter. The first end is having a height of 1 meter, and the second end is having a height of 1.6 meters. The formation width B is given to you as 10 meters, and the side slopes are given to you as 2:1, S:1. S here is 2. Assume that there is no transverse slope. So बहुत ही सिंपल एग्जांपल है. आप लोग ट्राई करें और मुझे आंसर बताएं. चले कोई मुझे ये बताते कि करेंगे कैसे, स्ट्रेटेजी बता दें.
सर ट्रेपेजियम बनाएंगे.
जी
ट्रेपेजियम बनाएंगे सर, ये इसमें क्या नहीं.
आप कोई भी तरीका यूज कर सकते हैं.
सर तो पहले एक इमेजिनरी ट्रेपेजियम बनाएंगे, उसको डायमेंशनिंग देंगे.
अभी हमने 3 मेथड्स डिस्कस किए थे, मिड सेक्शनल एरिया मेथड, मीन सेक्शनल एरिया मेथड एंड ट्रेपेजॉइडल मेथड. तो इनमें से कोई भी चले. आप अगर मिड सेक्शनल एरिया मेथड से मैं कहूँ आपको कि सॉल्व करें तो फिर कैसे करेंगे?
Shall we have to value the value?
Sorry?
I said I will calculate the value and then I'll tell you.
आप कोई मुझे स्ट्रेटजी बताते करेंगे कैसे, पहले क्या करेंगे, उसके बाद स्टेप क्या होगा, तीसरा स्टेप क्या होगा?
ट्रेपेजाइडल से होगा सर।
वो तो हर हर तरीके से होता है, तीनों तरीकों से होता है, लेकिन मुझे एक बता दें कि चले मैं कहता हूँ आपको कि मीन सेक्शनल एरिया मेथड या मिड सेक्शनल एरिया मेथड में से दोनों में से एक को मैं फॉलो करूँ, तो मैं क्या करूंगा पहले? चले मिड सेक्शनल एरिया की बात कर लेते हैं। चलिए मिड सेक्शनल एरिया में करते क्या है, ये पता है आपको? मीन सेक्शनल एरिया का पता है?
सर सर उसमें दो एरियाज लेते हैं, उसको टू पे डिवाइड करते हैं और जो टोटल लेंथ है उसको मल्टीप्लाई करते हैं।
यस, वेरी सिंपल। मीन सेक्शनल एरिया में हम दो एंड्स के एरियाज ले लेते हैं, दोनों को ऐड करके डिवाइड बाय 2 कर लेते हैं, हमारे पास एवरेज एरिया आ जाता है, और उस एवरेज एरिया को हम टोटल लेंथ ऑफ द रोड सेगमेंट से मल्टीप्लाई कर देंगे, हमारे पास टोटल वॉल्यूम आ जाएगा। इतना सिंपल सा क्वेश्चन है। अगर आप इसको मिड सेक्शनल एरिया मेथड से करते हैं तो आप दोनों डेप्थ्स लेंगे, डेप्थ्स दो एंड्स पे दी हुई है आपको, 1 मीटर है और 1.6, उसका एवरेज लेंगे और उस एवरेज डेप्थ की बेस पे आप एक एरिया कैलकुलेट करेंगे, बी डी प्लस एस डी स्क्वायर। उस एरिया को आप लेंथ से मल्टीप्लाई कर देंगे और आपके पास क्वांटिटी आ जाएगी। समझ आइए अब?
यस सर।
तो यही काम यहाँ पे भी हुआ है। यस,
I found 3952 m square.
3952.
Yes.
It is near to these values, but I don't know why it is 3952. Which method you have used?
I used the average of D to find the area.
The average of D.
Yes.
So you have followed this first method. So you have calculated the average of D, 1 plus 1.6 divided by 2. This is 1.3.
Yes.
Compared with your values, you have taken the average of this two depths. 1.3 is the average of these two depths. Now 1.3 is used for calculating the uh, uh, area of the section at the midpoint.
Yes.
So this will be BD plus SD square. So B is given to you as 10 meters. D is now average D, which is 1.3 plus SD square. S is given to you as 2 into D is again 1.3, so 1.3 square into this will be the area, and if you multiply it with the length of the road segment into 200, this will give you the volume.
Okay.
So
That means
this
you having to multiply S by D and then make a square root of them. Just D square multiplied by S.
sorry,
It is BD plus SD square. I
yes,
said SD square. I mean, we have to multiply S by D and then take the square of it, or just
no,
the D.
the square is only on the D.
Okay.
This is not whole square, this is on D only. Okay. The other method is you have to calculate the areas of the road section at these two ends. At the end where road height is 1 meter, at the end where road height is 1.6 meters. So you have calculated two areas, BD plus SD square, based upon this formula. So now calculate the average of these two areas, A1 plus A2 divided by 2. And then multiply that area with the length of the road segment, and you'll get the total quantity of the material. Is it okay?
यस सर, लेकिन ये इन तीनों मेथड्स में एग्जैक्ट कौन सा ज़्यादा एग्जैक्ट है, मतलब एक्यूरेसी के लिहाज से अगर हम देख लें तो?
I'll go for the mean sectional area method. जो mean sectional area method है, that is much accurate, but the accuracy also depends upon the distance between the road sections. अगर आप छोटे छोटे sections लेते हो तो उसकी accuracy increase होती जाएगी, जो भी method हो.
ठीक है।
Then there is an example number 2. This example is asking you to calculate the area of the side slopes of a portion of a bank for a length of 200 meters. The heights of the banks at two ends being 2.5 meter and 3.5 meter, and the ratio of the side slope is this one, 2:1. If the side slopes are to be provided with 15 centimeter thick stone pitching, calculate the cost of the pitching at the rate of ₹150 per cubic meter. आप लोग दोबारा से क्वेश्चन रीड करें और मुझे एक्सप्लेन करें इसमें करना क्या है. I'll ask randomly from you people. जी, लगता है मुझे खुद पूछना पड़ेगा. मोहम्मद साद.
सॉरी सर, नहीं समझ आई क्वेश्चन की.
अच्छा, फारूक अहमद, आप बता दें.
जी सर.
क्वेश्चन की समझ आई है क्या कह रहे हैं?
सर टाइम लगेगा. हाँ,
नहीं, टाइम लगेगा किस चीज में?
और सोल्व करने में.
सॉल्व नहीं करें, मुझे बताएं कि क्वेश्चन में मांगा क्या हुआ है. सॉल्व तो फिर कर लेंगे आराम से, कह रहे हैं.
सर ऑलमोस्ट सेम है वो पहले वाले से सर.
ऑलमोस्ट सेम है.
यस सर.
तो डिफरेंस क्या है? मतलब कुछ डिफरेंस होगा तभी आप कह रहे हैं ना ऑलमोस्ट. तो डिफरेंस क्या है?
स्लोप में डिफरेंस है सर.
स्लोप तो सेम ही है, 2:1.
अच्छा 1:2 और 2:1 सेम
अब
है सर.
बताएं, क्वेश्चन रीड ही नहीं किया शायद आपने.
सर 1:2.
अच्छा, चलिए और बताएं क्या डिफरेंस होगा.
सर हमें जो है लेंथ गिवन है और एंड पॉइंट्स गिवन है सर, उसके हाइट्स गिवन है हमें, तो उससे सर हम जो है एरिया फाइंड करेंगे स्लोप्स का.
अच्छा ठीक है, एरिया फाइंड करेंगे स्लोप्स का. और फिर एरिया. जी
सर अमाउंट ऑफ कट फाइंड करेंगे इसमें, बेसिकली जो हाइट दिया हुआ है.
इसमें अमाउंट ऑफ कटिंग या फिलिंग नहीं फाइंड करनी.
जी सर.
इसमें आपने फाइंड करना है. लेट मी ड्रॉ अ फिगर. या चलें फिगर एक बनी भी हुई है, उसमें ही देखते हैं. मैं आपको हाईलाइट कर देता हूँ. ये आपको यहाँ पर इस सेक्शन पे रोड की हाइट दी है और इस सेक्शन पे रोड की हाइट दी है, आपको जो है रोड की लेंथ भी गिवन है, ठीक है। आपको ये साइड स्लोप भी गिवन है, साइड स्लोप कितना है, 2:1 है। आपने कैलकुलेट करना है ये जो रोड की साइड्स हैं इनका एरिया क्या होगा, टोटल एरिया, ठीक है। ये आपने कैलकुलेट करना है, इस साइड का भी और इसकी इस साइड पे जो साइड है उसका, दोनों साइड्स का। ये आपसे क्यों मांग रहे हैं, क्योंकि आपने देखा होगा कहीं पे जब आप इस तरह के साइड स्लोप्स होते हैं तो उन पे वो स्टोन पिचिंग की जाती है। स्टोन पिचिंग, डू यू नो स्टोन पिचिंग? नेट पे कभी
यस
सर्च
सर।
करें, वो आप
यस
देख
सर।
लेंगे, आपको याद आ जाएगा क्या होता है। वो पत्थरों से बनाते हैं, वो एस्थेटिक्स के लिए भी होता है और वो सॉइल को रिटेन करने के लिए भी होता है।
स्लोप
सर ये
स्टेबिलिटी के लिए प्रोवाइड
हजरवे
किया जाता है
मोटरवे पे
मेनली।
उन्होंने सारा ये ऑलमोस्ट ये किया है।
जी जी बिल्कुल। तो अब इन्होंने ये करना है यहाँ पे साइड्स पे, तो इसके लिए इनको एरिया चाहिए साइड्स का, तो ये कैलकुलेट करना चाह रहे हैं ये साइड्स का एरिया। तो ये कैसे कैलकुलेट होगा, आपको डी गिवन है, आपको साइड स्लोप्स गिवन है, तो ये कैसे कैलकुलेट करेंगे?
Sir, first you have found the hypotenuse length and then
Yes,
multiplied.
hypotenuse length and then multiply it with the length of the road
Length.
segment.
Yes, it's come
How?
out like 447.2.
Yes. Now, how I will find out the hypotenuse length? This is,
Meaning 1 square plus 2 square, take a square root of it.
but the perpendicular side, this vertical side, is having different value at this point and different at this point.
सर दोनों का एवरेज लेंगे।
Yes, दोनों का average ले लेंगे. So you will get a height at this point. Alright?
And then multiply by the length.
Yes. So if I draw the triangle, ये आपके पास एवरेज डी आ गई और ये आपके पास हो जाएगा क्या, if this is S/1, this will be SD, ऐसे ही होगा ना कि नहीं?
Yes sir.
Yes, sir.
Okay, so hypotenuse will be equal to H is equal to D square plus S D whole square and under the root. Now you can see that in this equation D square is common. So if I take common, if I take D square as common, so this will be out of bracket and let me write D square is common, so this will lead to 1 plus S square. Alright. Now this square will cancel with the square root and the remaining will be D into under the root S square plus 1. So this will be the hypotenuse. Let's see. So look at this formula. This is the same which I have derived now. So the sloping sloping breadth or the hypotenuse is equal to D into under the root S square plus 1. You have to calculate the sloping breadth This will comes to be 6.71. Now multiply this with 6.71 with the length of the road, and multiply it with the 2, so that you can get area of two sides or two hypotenuse. So this will give you the area of two hypotenuse as 2684 square meters. Now it is asking that if I want to do the stone pitching having a thickness of 15 centimeter, what will be the cost? If the cost per cubic meter is 150, so simply multiply this area 2684 with this thickness, which is 0.15 in meters. So 0.15 into 2684, this will give you the volume of stone pitching, and multiply it with the unit cost, which is 150 rupees per cubic meter, and you'll get the total cost of the stone pitching. ठीक है?
Yes, sir.
Okay. Let's move towards the example number 3. Now read this question and try to understand. इसमें क्या मांगा गया है?
The amount of cut and fill.
Amount of cut and fill. आपको given data क्या है?
सर reduce level दिया है change और reduce level.
चेनेज और रिड्यूस लेवल्स दिए हुए हैं, आपको रोड की विड्थ दी हुई है, आपको साइड स्लोप्स दिए हुए हैं, फॉर्मेशन लेवल का स्लोप भी दिया हुआ है. So let's draw a graph on the graph paper. यहाँ पे तो ऑलरेडी बना हुआ है, लेकिन जब आप एक्चुअली सॉल्व करेंगे तो यू कैन यूज अ ग्राफ पेपर, यू कैन यूज दी एक्सेल. So horizontally this is showing you the distance in meters. ठीक है? Now this is the portion which is showing you the chainage. This is chainage 10, this is chainage 11, this is given to you. chainage 10 पे इतना reduce level है ground का, chainage 11 पे इतना reduce level है, chainage 12 पे इतना है. And this is also given to you that each chain is having a length of 30 meters. So at chainage 10, what will be the distance from 0 point? Definitely 10 times 30, so 300. Then at chainage 11, this will be 330. Then chainage 12, this will be 360. Then at chainage 13, this will be 390, and so on. Then in this row, they have mentioned the reduced level of the ground at each chainage. So at each chainage, they have mentioned the reduced level of the ground, which is given to us 105, 105.6, 105.44, 105.9, and so on. यहाँ पे सारी ये values mention करते हैं. Now I need the reduced level of the formation. I need the height of bank. I need depth of cutting, if any. अभी मुझे नहीं पता इसमें कटिंग है या नहीं जब तक मैं ग्राफ नहीं बना लेता, या मैं हाइट या ये कैलकुलेशन नहीं कर सकता, पॉजिटिव आ रही है या नेगेटिव आ रही है. जब तक ये मैं नहीं करता तब तक मेरे पास ये नहीं पता चलेगा कि मुझे ये नहीं पता चलेगा कि यहाँ पे कटिंग है या फिलिंग है. So I need to calculate first of all the reduced level of the formation. तो reduced level of the formation कैसे calculate करेंगे? आपको सिर्फ एक ही वैल्यू दी गई है, reduced level of formation is 107 at chain age 10. बाकी आपको वैल्यूज नहीं दी गई, कैसे कैलकुलेट करेंगे?
By subtracting
what?
from the formation one.
No, that is, I'm not asking you the height of the bank or depth of cutting. I'm asking you what will be the reduced level of the formation. Once you know the reduced level of the formation, then you'll be able to calculate the height of bank or depth of cutting by subtracting the formation level from the ground level, or ground level from the formation level.
सर ये रिड्यूस लेवल ऑफ ग्राउंड से उसको माइनस करेंगे?
देखिए, आपको यहाँ पे बताया गया है कि 107 इसका फॉर्मेशन लेवल है एट चैनल 10. बाकी आपको नहीं बताया गया कि इस जगह पे फॉर्मेशन लाइन का रिड्यूस लेवल क्या है, इस पॉइंट पे रिड्यूस लेवल क्या है, इस पॉइंट पे क्या है. इन्होंने हमें ये बताया कि स्लोप इस पॉइंट से ऑनवर्ड जो है 1 डाउनवर्ड स्लोप है, और स्लोप जो है 1 in 150 है. 1 unit drop in every 150 यूनिट हॉरिजॉन्टल डिस्टेंस. देन जो है उसका चेन एज 14 तक यही स्लोप चल रहा है, चेन एज 14 तक. फिर आप देखेंगे चेन 14 के बाद इसका स्लोप चेंज हुआ है, तो स्लोप चेंज हुआ है, और चेंज होने के बाद क्या हो गया, डाउनवर्ड ग्रेडियंट इन 1 in 100. तो स्लोप से हम रिड्यूस लेवल्स कैसे कैलकुलेट करेंगे? Very simple. You don't know the method of cross multiplication.
नो सर.
देखें, ये आगे जो है ये वैल्यू आपको पता है, ये आगे जो है स्लोप डिक्रीज हो रहा है एट अ कांस्टेंट रेट. स्ट्रेट लाइन है ना, इट्स अ स्ट्रेट लाइन. सो इट मींस दैट फॉर एवरी इंटरवल अ कांस्टेंट वैल्यू इज सब्ट्रैक्टेड फ्रॉम दिस प्रीवियस वैल्यू, तभी जाके आपके पास नेक्स्ट स्लोप आ जाता है. तो वो वैल्यू हमने कैलकुलेट करनी है कि कितना हम माइनस करेंगे हर एक 30 मीटर्स के बाद. सो आपको गिवन है, यू आर गिवन दैट there will be 1 unit drop after 150 units of horizontal distance. 1 unit drop after 150 units of horizontal distance. अब आपके पास चेनेज कितनी है? चेनेज हॉरिजॉन्टल डिस्टेंस कितना है चेन का? 30 मीटर्स.
यस सर.
तो आपके पास अगर 1 मीटर ड्रॉप है आफ्टर 150 मीटर्स, तो आपको कैलकुलेट करना है कि आपके पास कितने मीटर्स ड्रॉप आता है आफ्टर 30 मीटर्स. तो लेट्स से मेरे पास x मीटर ड्रॉप आता है आफ्टर 30 meters. Now if I cross multiply these two values, तो 30 multiply by 1, this will be equal to x multiply by 150. अब I need the value of x, तो x की वैल्यू कैलकुलेट करें क्या है?
Yeah,
0.2 सर.
0.2.
2. Yeah.
0.2 मीटर ड्रॉप हो रहा है हर 30 मीटर के बाद. हर एक 30 मीटर के बाद आपके पास 0.2 मीटर्स का ड्रॉप हो रहा है. तो अब यहाँ पे आपके पास लेवल है रिड्यूस लेवल फॉर्मेशन का 107. तो आफ्टर 30 मीटर्स, ये 30 मीटर है, यहाँ पे जो रिड्यूस लेवल होगा वो इससे 0.2 मीटर्स कम होगा. फिर यहाँ पे जो रिड्यूस लेवल होगा वो यहाँ से 0.2 मीटर्स कम होगा एंड सो ऑन टिल दिस पॉइंट, बिकॉज यहाँ तक स्लोप जो है 1 in 150 है। तो अब क्या करेंगे, 107 minus 0.2 106.8, then 106.8 minus 0.2 106.6, 106.6 minus 0.2 106.4 and again 0.2 106.2। अब यहाँ से ऑनवर्ड जो है स्लोप चेंज हो गया है। दिस इज नाउ डाउनवर्ड ग्रेडियंट 1 in 100। सो सिंपली आप क्या करेंगे कि यहाँ 150 की बजाय 100 कर लेंगे। अब इस बेस पे x की वैल्यू चेक करें क्या आती है। आपके पास 1 मीटर ड्रॉप हो रहा है 100 मीटर्स के बाद, तो x मीटर ड्रॉप होगा 30 मीटर्स के बाद। क्रॉस मल्टीप्लाई करें क्या आता है इससे और x की वैल्यू कैलकुलेट करें।
0.3 सर।
0.3। सो अब इसके ऑनवर्ड्स आप देखेंगे कि 0.3 का डिफरेंस आ रहा है। 106.2 minus 0.3 you will get 105.9, 105.9 minus 0.3 105.6, 105.6 minus 0.3 105.3 and so on। ठीक है आखिर तक। अभी आपके पास आ गई रिड्यूस लेवल ऑफ द फॉर्मेशन। अब इससे आप हाइट ऑफ बैंक और डेप्थ ऑफ कटिंग कैलकुलेट कर सकते हैं। कैसे? फॉर्मेशन लेवल के रिड्यूस लेवल को से माइनस कर दें रिड्यूस लेवल ऑफ द ग्राउंड। तो 107 minus 105 this will give you 2, 106.8 minus 105.6 so this will give you 1.2, 106.6 minus 105.44 this will give you 1.16 and इसी तरह आप तमाम वैल्यूज के तमाम सेशंस के लिए आप वो तमाम चेंजेस के लिए आप ये हाइट ऑफ बैंक्स या डेप्थ ऑफ कटिंग फाइंड आउट कर लें। अब डेप्थ ऑफ कटिंग हमारे पास यहाँ पे कोई भी नहीं आ रही क्योंकि तमाम की तमाम पोर्शन जो है फिलिंग में है। अगर यहाँ पे हमारे पास कोई नेगेटिव वैल्यू आती है तो हम जो है कटिंग में लिख देंगे, लेकिन हमारे पास कोई भी फिलहाल कटिंग में नहीं आ रही। सो यहाँ तक आपका हो गया कैलकुलेशन ऑफ द हाइट ऑफ बैंक और डेप्थ ऑफ कटिंग। अब इसको एक टेबल फॉर्म में लिख लेते हैं। नाउ वी कैन कन्वर्ट दिस ऑल इंफॉर्मेशन इन अ टेबुलर फॉर्म। The table will be similar to the table which we have discussed in this portion. So just copy and paste these values here. For example, changes की बात की जाए तो change 10, 11, 12, 13, 10, 11, 12, 13, 14. Length is 300, 330, 360, 390 and so on. Height or depth you have calculated already. 2, 1.2, 1.6, 1.16, 0.5. So all of these values are written here. Now we are calculating the volumes by using mid-sectional area method. So calculate the average of these two depths, 2 and 1.2. This will give you an average of 1.6. Then calculate the average of 1.2 and 1.16. This will give you 1.18. And then calculate the average of 1.16 and 0.5 and this will give you 0.83 and so on. Now calculate the central area which will be equal to B times D. B is given to you as 10 meters and D is the average D you have calculated. So BD will come from here. Then SD square, SD is S is 2 and D you already have calculated. Total area will be equal to BD plus SD square. This column plus this column. Distance between these distance between each chainage is 30 meters. So I've written 30 for all of these values. Now multiply this 30 with the total area for each chainage, and you'll get the volume of earthwork for each road segment. At the end, add up all of these volumes, then you'll get the total volume of the earthwork. After getting the total volume of earthwork, if you know the rate of the earthwork, then you can simply calculate the total cost of the earthwork. So the rate of earthwork is given here as 275 rupees per 100 cubic meters. Per 100 cubic meters, but the quantity of earthwork we have calculated is in cubic meters. So you must have to make both of these values compatible before multiplying them. So how can you do this? You can do this by dividing this 275 by 100, and you will get 2.75 rupees per cubic meter. Multiply this 2.75 rupees with 3513.6 cubic meters, and you will get the total cost of excavation. Now add contingency charges, etc. 5%. So this will give you 483 for contingency charges. Add this with the total cost of the excavation, and you will get the grand total cost of the excavation. Is this clear?
Yes, sir.
Okay. So you have calculated the volume of earthworks. Now you have to calculate the site areas. Similar to what we have calculated in the previous example. ये जो साइड एरियाज हैं इसके वो कैलकुलेट करने हैं, क्योंकि हमें क्वेश्चन में सेकंड पार्ट में हमें पूछा गया है फाइंड द एरिया ऑफ द साइड स्लोप्स एंड द कॉस्ट ऑफ टर्फिंग। इन्होंने अब यहाँ पे साइड स्लोप्स पे घास उगानी है, so they want to grow the grass on the side, so they want to calculate the area of the side slopes, and the turfing rate is given to you as 60 rupees per square meter per 100 square meter. So how you will calculate this area of the side slopes? In the same manner, but you have to organize the data in a proper table. So let's say these are the changes points 10, 11, 12, 13, 14 and so on till 20. Height or depth you have calculated already, 1.2, 1.16, 0.5, and take the average of every two heights, every consecutive two heights. 2 and 1.2 will give you 1.6, one average of 1.2 and 1.16 will give you 1.18 and so on. Now you have already derived a formula for side slopes, length of the side slope or hypotenuse in the previous example, which was d under the root s square plus 1. D under the root s square plus 1. So put d in this formula, and you know the value of s. S is 2, and calculate the length of the side slope, or you can say that hypotenuse. So the hypotenuse values of hypotenuse at each section is given in this table. ठीक है, हर एक चैनज पे जो उसकी साइड स्लोप की लेंथ होगी या ब्रेड्थ होगी या आप हाइपोटेन्यूज कह लें व्हाटएवर, तो वो आपने कैलकुलेट कर ली यहाँ पर. नाउ मल्टीप्लाई दिस hypotenuse with the length of that road segment, and you will get the area of the side slope for that road segment, and this will be area of side slope of one side. Now multiply it with 2, and you will get the total area of both sides, and calculate this, do this calculation for all of these changes points and add them all, and you will get the total area of the side slope. Now you are given that the cost of the turfing is 60 rupees per 100 square meter, but we have the quantity in square meters, not in 100 square meters. So convert this square meters into 100 square meters into just square meters. So for that purpose, you have to divide this by 100, and you will get 0.6 rupees per square meter. Multiply this with this total area, and you'll get the total cost, 778 rupees, 778.68 rupees. Add contingency charges 5%, and then add them both, and you'll get the grand total cost of the turfing. So this was all about the today's lecture, and this was all about the quantity survey course. अगर आपको कोई इशू है तो आप मुझसे पूछ सकते हैं. अगर आप कोई एक्स्ट्रा टॉपिक डिस्कस करना चाहते हैं तो we have another extra week, and if you have any difficulty or you want me to discuss any topic, so most welcome. मैं आप मुझे टॉपिक बता दें, I'll discuss.
सर टॉपिक से अलावा कुछ?
टॉपिक से अलावा तो आप लोग सजेस्ट करें.
सर क्विज के बारे में. सर
क्विज़ेस के बारे में?
हाँ सर.
आते आते एकेडमिक्स पे आ गए.
सर आपने क्विज नंबर 1 हमारा एक्सेप्ट नहीं किया था सर.
यस सर, वो उसका भी सर कुछ करे. और सर ये लॉन्ग होम असाइनमेंट में अगर उस पर थोड़ी डिस्कशन हो जाए.
अच्छा, लॉन्ग होम असाइनमेंट जो है आप लोगों ने देखी है वैसे?
यस सर.
उसमें क्या आपको इशू आ रहा है?